Hello everyone, this is Adnan. Welcome to Chemistry with Adnan. On this channel, we are covering the entire IGCSE Chemistry 0620 syllabus. And if you want to join group lessons that I offer, you can join my school community on school.com, SKOOL. It's a high school chemistry. The name is High School Chemistry, where I offer weekly lessons. Once a month. It's a free package, and if you want to join, weekly lessons, so you can subscribe for the premium subscription. And if you want one-on-one lessons, you can fill out this Google form that I've linked below, and the link to the school community is also in the description. Okay, so this lesson is going to be a bit longer than the others because this is 2.4 chapter 2. Topic is for 2.4 ions and ionic bonds. So in the core syllabus, we have the first topic, which states that describe the formation of positive ions known as cations, and as negative ions known as anions. So this is relatively simple. We already know that when atoms they lose electrons, they get a positive charge, and lithium, since it is in group 1, it's going to lose one electron, and it will form a positive ion, Li plus, which we call a cation because it has a positive charge. And fluorine, say it is in group 7, it's going to gain one, and to have a complete outer shell, and it will form an anion. So basically, in this topic, what we try to cover is that how to identify that which specific element will form what type of a bond. So let me explain that. Let me paste a periodic table here. Just give me a second. And from the periodic table, I will explain that how to identify that which element will form what type of ion. So basically, group 1 elements, what you need to know that group 1 elements, they will lose one electron and they will have a +1 charge. Group 2, they will lose 2 electrons and they will have a charge of +2. And for group 3, they will lose 3 electrons and they will have a charge of +3. Examples from group 1, it's sodium. So sodium will have a charge of +1. Any member of group 1, it will have a charge of +1 when it forms ionic bonds. And group 2, like calcium, for example, so calcium will form a 2+ ion. And from group 3, aluminum and all others, they will form ions with a charge of 3 positive, right? So this is how basically we identify that which element on the periodic table, whether it will form a cation or an anion, and what will be the charge on that anion or a cation, right? So similarly, those elements that lose electrons, they are called metals, and group 1, 2, and 3, they are losing electrons, so these are metals. So now we skip group 4 and we move on to group 5. So group 5, now these are non-metals and they start to gain electrons to have a complete outer shell. So group 5 elements, they will gain 3 and they will have a charge of -3. Group 6, they will gain 2 and they will have a charge of 2-. And group 7, they will gain 1 and they will have a charge of -1. So what will be the examples now? For nitrogen, it is in group 5, it will be 3 negative. Oxygen is in group 2, it will be 2 negative. And group 7, since it is gaining one. So fluorine or chlorine, bromine, iodine, any atom from any element from group 7 or any atom from group 7, it will gain one electron and it will have a charge of negative. So metals, they form cat ions, remember that, and non-metals, they form anions. All right, so I'm going to paste the periodic table here, and I'm going to show you the individual like groups as well, right? So here you can see that this is group 1. So lithium, sodium, potassium, rubidium, cesium, francium, all of them, they will have a +1 charge when they combine with non-metals, right? Remember that. Like you can see that in all of, we have discussed this before, that in group 1 we have one outer shell electron. There is only one electron in the outer shell. So in order to complete their outer shell, these metals, they lose that a single outermost shell electron in order to have a complete electronic shell. And similarly, this is group 2. So these ions, these elements, they will form ions with +2 charge. This is group 3, boron, aluminum, gallium, indium, thallium. So this will be +3. And nitrogen, this group 5, it will be -3. Oxygen, it will be -2, because in group 6 they have 6 electrons in the outer shell, and they need only 2 more to have a complete outer shell. And for group 7, there are already 7 electrons, so they will gain 1 more and they will have a -1 charge. So this is what you need to remember, and this is what you need to understand basically in this topic, which states that describe the formation of positive ions known as cations, and negative ions known as anions. Okay, so the next one is state that an ionic bond is a strong electrostatic attraction between oppositely charged ions. Yeah, so an ion is an atom or molecule with an electrical charge. We already know that, and due to the loss or gain of an electron, right? So the overall charge of an atom is 0. Like, because for a neutral atom we have the same number of protons and electrons. For example, for hydrogen, we have 1 proton in the nucleus, and there's 1 electron revolving in its for outer shell. So it's electrically neutral, right? So state that ionic bond is a strong electrostatic attraction between oppositely charged ions. So when atoms lose electrons, they get a positive charge, and ionic bonds form between a cation and anion, right? So ionic bond, it is a bond formed between a positively charged cation and a negatively charged anion, right? They are oppositely charges, and they oppositely charged particles, and this bond is a strong electrostatic attraction. So the force that attracts them, that is called electrostatic force of attraction, right? So this is called the electrostatic force of attraction. Okay, so yeah, so this is a force between the oppositely charged ions, and an electron is transferred from the cation to an anion, which gains an electron. For example, we have a bond between lithium and fluorine. So lithium is going to lose 1. So let me draw the electron diagram for lithium. Well, I'm covering this another topic, the upcoming topic with this one as well. Describe the formation of ionic bonds between elements from group 1 and group 7, including the use of dot and cross diagrams. So let me draw it here. So let's say a lithium and fluorine, they wants to make a bond, a lithium fluoride. they make this molecule. So now let us see the formation of this. So lithium, since it has two electrons in the first and one in the second, and it's a metal and it wants to lose this electron, so it will lose this electron, this outer electron, and it will turn into a positive ion with only two electrons now, but with a full outer shell, right? So this will be lithium positive. So now this is an ion and a cation with a positive charge. Similarly, okay, now that this electron that lithium lost, now if we look at the structure of fluorine, for example, so fluorine has two electrons in the first shell and seven electrons in the second, because its atomic number is 9. So 2 plus 7, 9. So 1, 2, 3, 4, 5, 6, and 7, right? So now this eighth electron, the electron that lithium lost, it will be gained by fluorine. And I'm going to draw this in red because to denote that it came from lithium, right? Let me just change the color here as well. Yeah, so now this is how we draw the dot and cross diagrams. And yeah, let me just read it again to see whether I explained everything related to this. Describe the formation of ionic bonds between elements from group 1 and group 7, including the use of dot and cross diagrams. Yeah, that's it. So you can also practice other combinations from group 1 and group 7. For example, try to make a bond between sodium and chlorine, or rubidium and bromine. And let's see how do you draw these. Another thing, when you draw these, so when you mention one atom, so you mention, when you draw one atom, you mention its electrons using a cross. So for example, lithium, for example, so it should be like this. So these cross, and then we have another cross here. Let me draw it in red. And for fluorine, yeah, we maintain the dots. And I'm going to change this red dot here from a red cross. So this will be yeah, a cross, right? So this is called a dot and cross diagram. And yeah, I forgot to add a negative charge here surrounding fluorine, right? Like this. Yeah. So now you can see that these are oppositely charged particles. We have a cation of lithium and anion of fluorine. And since they have oppositely charged, since they are oppositely charged, so they will be attracted strongly by electrostatic force of attraction. And this is basically how ionic bonds are formed. So next one is describe the properties of ionic compounds: high melting and boiling points, good electrical conductivity when aqueous or molten, or poor when solid. Okay, so properties of ionic compounds, they are crystalline, right? They are crystalline. They have a crystal like lattice. What is meant by crystal lattice? Like these oppositely charged particles, they are perfectly arranged in geometrical order, repeating after like they repeat their pattern in three-dimensional space. So that is called a crystal lattice, right? So a positive and negative and positive and negative and so on. So these are this is basically what a crystal lattice is. So they have a giant ionic structures, right? And that is why, since they exist as a giant ionic structures and in crystal lattice, so these bonds are very strong, and they are very difficult to break, right? Like they consume a lot of energy to be broken. And That is why they have ionic compounds. Since they exist as giant ionic structures, they have high melting and boiling points, right? Why? Because lots of energy is required. Energy is required to break these strong electrostatic forces of attraction. Electrostatic forces of attraction, right? All right. So this is why uh, ionic compounds, they have high melting and boiling points. Okay, so good electrical conductivity when aqueous or molten. Okay, so we need to understand that why anything that conducts electricity, right? So anything will conduct electricity if that substance has free moving electrons or ions. So in the case of ionic compounds, when we melt this crystal, the ions, they get broken from the crystal lattice, they melt, and or like, let's say if we dissolve this in water, so the crystal structure dissolves, and now in a liquid state, whether it's aqueous or molten, these ions which were once locked in a crystal lattice and they were unable to move, in a liquid state now they are able to move. Let's say this is a crystal of sodium chloride, and now we need to, now these ions Na plus and Cl minus, in a liquid state, they can flow, they can move, and since these ions are able to move now, that is why ionic compounds, they conduct electricity in a liquid state, right? So, and again, why they are poor conductors, or they don't conduct electricity when in a solid state. That is the reason is that the ions cannot move, right? And that is why they they don't conduct electricity in a solid state, and they have a good electrical conductivity when aqueous or molten. Why? because because ions can move. Not, don't write electrons. This is very important. This is the key word, because ions can move, right? So I hope this point is clear now. Now we are moving on towards the supplement and extended topics. The first topic is describe the giant lattice structure of ionic compounds as a regular arrangement of alternating positive and negative ions. So I think I talked about this already in the previous one, in our previous topic. So let us talk about it again. We can, an ionic compound has a giant lattice structure, right? Which means that the cations and anions are arranged alternately. So if I draw a structure of sodium chloride, actually I can copy this one. Right. So yeah. So let me just draw it like this, and then this. My drawing is not that perfect, but I mean, you can imagine, like this is a structure. So we have Cl minus, Na plus, Cl minus, and then Na plus, right? So and then this will be Cl minus, this will be Na plus, and then again a layer of Cl minus, and this will be Na plus, and this will be Cl minus, and so on, right? So this is basically what a crystal lattice looks like. So sodium chloride, we can depict it like this. So the ionic lattice is held together by strong electrostatic forces of attraction, like which in other words are ionic bonds between the cations and anions, right? And now the next topic is describe the formation of ionic bonds between ions of metallic and non-metallic elements, including the use of a dot and cross diagrams. So metals, again, they lose electrons. For example, magnesium, it is in group 2. So in order to have a complete outer shell, it would lose 2 electrons and it will change into a magnesium 2 plus ion with its you know outer shell complete with 8 electrons. And chlorine, for example, it is in group 7, so it's going to gain 1 electron, and it will have its complete outer shell. So now let's say magnesium and chlorine, they wants to join together and they make a bond. So how will that look like? So you can see here that magnesium is losing 2, or one magnesium atom is losing 2 electrons, and chlorine, each chlorine atom is gaining 1. So we need another chlorine atom so that it can take another electron which is being lost by magnesium. So in order to make a bond, or to write the formula of this compound, we will need 1 magnesium, so, and we will need 2 chlorine atoms, right? So I'm only drawing their outer shells. So in magnesium, so we let's there are 2 electrons which magnesium is going to lose, and chlorine, I'm drawing these 7 electrons: 1 2 3 4 5 6 7, and 1 2 3 4 5 6 and 7. So now from magnesium, this electron, it will be gained by one chlorine, and the second electron, it will be gained by another chlorine, right? And magnesium will get a 2 plus charge, and chlorine, it will get each chlorine will have a 1 negative charge, right? So yeah, so this is how basically they make a bond, they form a bond, and the formula will be MgCl2. And now they're held together by strong electrostatic forces of attraction. So I think I should have drawn the the 3 shells of magnesium. Let me draw the whole. So this is the first one, and this is the second one with 8 electrons now. And from the third one, it has lost these 2 electrons. 1 2 3 4 5 6 7 8. Yeah, so now you can see that all of these, they have a complete outer shell, right? I didn't draw the inner shell for chlorines, assuming that you understand this. If you don't understand this, let me know in the comments below. I may make another video on this. Okay, so this is basically describe the formation of ionic bonds between ions of metallic and non-metallic elements. Basically, it is saying ions of metals and non-metals, right? Including the use of dot and cross diagrams. So I think we can, uh, practice another molecule here, formation of calcium fluoride. So calcium has 4 shells. It is in period 4. So calcium molecule, calcium, electronic structure, it will look something like this. And it's going to lose 2 electrons because it is in group 2. So group 2 elements, they lose 2 electrons to have a complete outer shell. So calcium, 2 electrons in the first shell, uh, 8 electrons in the second. 1 2 3 4 5 6 7 8. 8 in the third. It has atomic number 20, so 20 electrons. So 8 10, 1 2 3 4 5 6 7 8. And now the fourth shell, it contains 2, 1 and 2. So for fluorine, it is in period 2, group 7. So it's going to gain one electron. It has two shells since it is in period 2. Two electrons in the first. It has atomic number 9. So calcium is 20 and fluorine is 9. So two electrons in the first and 1, 2. Okay, I should depict these using a cross because these are dot and cross diagrams. Okay, so 1, 2, and yeah, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and 7. 7 electrons in the outer shell. And the same will go for this another fluorine molecule, right? So let me just pick this. Yeah, and bring it on this side. Okay, so now these two electrons from calcium, they will be gained one each by these two fluorines, right? So this one is going to go to this one, and fluorine will have a one negative charge because it has gained one electron, so a -1. And this other one, this will go to the other fluorine atom, like this. And this fluorine will also have a one negative charge because it gained one electron from this calcium. And calcium, since it lost two electrons, so now the outer shell is gone, and the inner shell now, which it is complete with 8 electrons, right? And since it has lost 2 electrons, so I'm gonna give it a charge of 2 positive. So now we have oppositely charged ions, and they are being attracted by the strong electrostatic forces of attraction. And this is ionic bonding between calcium and fluorine. The formula will be CeF2, right? So yeah, I think now it's better. And so now the last one from last topic from extended 2.4, explain in terms of structure and bonding the properties of ionic compounds, high melting points and boiling points, and good electrical conductivity when molten or aqueous, or poor when solid. I think we have talked about this. I mean, why would they repeat this topic? This is also included in the previous section, I guess. Or I might have made a mistake in while copying it. So yeah, this one describe the properties of ionic compounds, uh, high melting and uh, boiling points. And I think for core, we just have to know that ionic compounds and have high and melting and boiling points. We don't need to explain it, right? And for extended, we need to develop our understanding that why ionic compounds have high melting and boiling points, and why they are good conductor of electricity in an aqueous or molten, and poor conductors of electricity when in a solid state. Yeah, so you just need to know here in core that ionic compounds, they have high melting and boiling points. No explanation. You don't need to know that why they have high melting and boiling points. Just need to know that they have high melting and boiling points. And you don't need to know the reason that why ionic compounds are good electrical conductivity. They have good electrical conductivity in liquid or molten state, and poor electrical conductivity in a solid state. So in extended, we explain these concepts, which I already explained, in relation to that topic in the core syllabus. So now I have included some questions from the past papers, right? So now this question, it states that state two properties of an ionic compound, right? So again, you can say that they have high melting and boiling points. So high melting and boiling points. And for the second one, you can say that conducts electricity when molten. Remember, you must write when molten, because they don't conduct electricity in a solid state. If you don't write the word when molten, you're not going to get any mark. So conducts electricity conducts electricity when molten, right? So I'm going to highlight this. This is the keyword. This is very important, and it must be in your answer. Otherwise, you're not going to get the second mark. Remember that. Okay. So from this next question, it says that this is again from a past paper. It states that figure 1.1 shows part of the periodic table, and answer the following questions using only the elements in figure 1.1. Each symbol of the element may be used once, more than once, or not at all. Give the symbol of the element that forms an ion with a charge of 2 negative. Again, we have already talked about this, that group 6 elements, they need to gain 2 electrons, because they already have 6 electrons and they need 2 more to make it 8 in order to have a complete octet. 8 electrons in their outer shells. So, in this diagram in figure 1, oxygen is mentioned. So, you can just write O, right? So this is going to give you, this is going to get you 1 mark. So, and what if I ask you that, pick an element that forms an ion with a charge of 3 plus. So comment the answer, below. Okay, so uh, so this is the question which you can answer in the comments. So question number 4. This question states that lithium bromide is a compound with ionic bonding. State the meaning of the term uh, ionic bond. So it is a strong electrostatic force of attraction. Whenever you are asked to define the term the like ionic bond, so this word electrostatic force of attraction, it must be there. Electrostatic attraction. It is strong electrostatic attraction between oppositely charged ions, between oppositely charged ions, right? So this statement, the first statement, that is going to get you 1 mark. Strong electrostatic attraction, and this statement up between oppositely charged ions is going to get you another mark. Okay, so the next question is uh, part B. Complete figure 8.1 to show the electronic configuration of a lithium ion and the charge on the ion. So here you can see that only the first shell is mentioned, which means that it has lost an electron. Normally, lithium has 2 shells. It belongs to group 1 period 2, so it will have 2 shells since it is from period 2. The atomic number is 3, so it will have 3 electrons, 2 in the first and 1 in the second, right? It has 3 electrons. The atomic number is 3. So here, since only 1 shell is, they have given us only 1 shell. So I'm going to draw 2 electrons here, and they will be negative, or you can write -1 charge, right? So, and you must fill this, the 2 electrons in the inner shell. So this is how you complete 8.1 to show the electronic configuration of a lithium ion. So when it has, oh, it is positive, right? Not negative. Okay, I'm glad I was able to, catch it here. So +1, right? Since it has lost an electron, so it will have a positive charge. Yeah. So yeah, I think these are pretty easy questions if you understand these concepts, and you can practice on your own, and you can join my school community on school.com. The name of the community is High School Community. It is free to join, where I offer a free lesson once a month. And if you wish to join the premium package, where I offer 4 lessons in a month, once a week, you can join that as well. And if you need one-on-one lessons, well, although the seats are very limited, you can fill out the Google form, which is given in the description, and the link to my community is also given in the description. If you're excited about chemistry, if you like chemistry, it is a good place to be. So I've made an entire video on that community, which is on the channel. So yeah, if you are new to school or if you don't know about it, you can watch that as well. So anyways, this will be all from my side for topic 2.4, ions and ionic bonds. And I hope to see you in the next one. Take care. Goodbye.